So for today, we're going to start looking at what's inside an atom or the atomic structure. So our target is to be able to describe the basic structure of an atom and to be able to identify the locations, charges, and names of the three main subatomic particles. So what is matter? Matter is anything that has mass and volume. Volume means the amount of space something takes up. So on page 68 of your notebook, you're going to create a T-chart and sort these items into matter and non-matter. And we'll check over those tomorrow. What is an atom? All matter is made of particles called atoms. Atoms are the building blocks of matter. They're the smallest component of an element that maintain the properties of that element.
I hope Zoe likes her birthday cake. At least if it's a disaster, you can use those artistic skills of yours to frost some birthday charm into the cake.
Oh, come on. It won't be a disaster.
How hard can it be, right? We'll just follow the recipe.
It's pretty sweet how just mixing a bunch of different ingredients together like this can make a totally new thing, huh?
It's totally sweet. Mixing up ingredients for a cake is a lot like what the universe does when it combines elements to make compounds.
We're making a cake, Mia. Don't get all sciencey on me.
It's true. When two or more elements are combined and a chemical reaction occurs, a brand new substance is created. That brand new substance is called a compound. It's sort of like this cake.
Mia, this cake is a yummy and delicious treat made of eggs, milk, flour, sugar.
Yeah, and the ingredients we combine to make a cake are like the elements that make up a compound. Elements are substances that cannot be broken down into something simpler. When we combine the ingredients and bake the cake in the oven, a chemical reaction occurs to make a compound. A cake.
So, elements are the ingredients for the universe?
Kinda, yeah. The universe combines elements to make compounds. There are 118 elements, and they're each listed on the periodic table. Every element has a symbol, too, like O for oxygen, or H for hydrogen.
That's a lot of ingredients.
I know. When we combine ingredients to make a cake, it's called a recipe. When elements combine to make a compound, it's called a chemical formula.
That sounds a lot more serious.
Not always. A chemical formula just shows the composition of the compound. Ever hear of H2O?
Yeah, it's water, right?
Yep. H2O is the chemical formula for water. Water is a compound. Its ingredients, the elements from the periodic table that make it up, are hydrogen and oxygen. H is the symbol for hydrogen. There are 2 atoms of hydrogen in water, so the chemical formula shows a 2 after the H symbol. That number is called a subscript. There is 1 atom of oxygen, so its O symbol is enough to tell us that. Put it all together, and H2O equals water.
Are there chemical formulas for everything?
Every compound, yes. Salt is a compound, too. It's called sodium chloride because it's made from the elements sodium and chlorine. So its chemical formula shows the symbols for those 2 elements together. NaCl.
Chemical formulas really are like recipes. You were right. The cake is like a compound. Little Miss Scientist strikes again.
See? Now it's your turn to explain, Sam.
All right, let's see if I've got the art of elements and compounds down to a science. An element is as simple as it gets. Elements are substances that can't be broken down into anything simpler. There are 118 elements, and they're all listed on the periodic table. Elements are combined to form compounds, totally different new substances. The recipe for a compound is called a chemical formula. Chemical formulas show the symbols for the elements that make up a compound, and subscripts that tell us how many atoms of each element are needed to make the compound. There, easy as pie.
Don't you mean piece of cake?
Elements and molecules. 2 or more atoms that are bonded together make a molecule. Molecules can be made of all the same or a combination of different elements. So here we have, for examples, like the caffeine molecule is made of carbon, hydrogen, nitrogen, oxygen. Oxygen can still be an element, but it can also be a molecule because usually you won't find oxygen by itself. So you'll see some elements that do bond with other atoms of the same element. So that's still a molecule. So anytime there are two or more atoms that are bonded together, that's going to be a molecule. So elements are made up of a single type of atom and can be found on the periodic table of elements. A substance that cannot be broken down into simpler substances by chemical means is an element. They are composed of atoms that have the same atomic number. That is, each atom has the same number of protons in its nucleus as all the other atoms of that element. So here we have hydrogen. We have 2 atoms of hydrogen. Or we can have 8 atoms of carbon bonded together, or just a single atom of oxygen by itself. They are all elements, but they're also molecules if there's more than one. For compounds, compounds have to be 2 or more different elements bonded together. So all compounds are molecules, but not all molecules are compounds. So water, ammonia, carbon dioxide, methane gas, all those are compounds because they are different elements bonded together, but they're also molecules. So hopefully it's not too confusing. So we look here, we have the first one. The diagram is showing an atom and an element. The second one is showing a molecule of an element because they're both the same. And then the third one is a diagram of a molecule of a compound. As long as you can identify when it's a compound and when it's simply an element, you're fine.
Hey, Sam. How's the drawing coming?
I really like drawing fruit, but these kiwi seeds are tough. They're the tiniest things I've ever seen.
They are teeny tiny, but I know something much tinier.
Tinier than that?
Sure. Atoms.
Mia, you can't even see atoms. That doesn't count.
We can see atoms, but only if we use a super strong microscope.
Are there atoms in those tiny kiwi seeds?
Definitely. Atoms are the tiny particles that make up all matter, and those seeds are matter. Believe it or not, atoms are so tiny that millions and billions of them make up that kiwi seed.
That's crazy. I can't imagine something that small. What are atoms supposed to look like?
Focus on this. Atoms are like itty-bitty balls. At the center of every atom is a nucleus. The nucleus is made up of particles called protons and neutrons. Protons have a positive electrical charge. Neutrons have none. They're neutral.
Got it. P for proton equals positive. N for neutron equals neutral. So all of that fits inside a tiny atom?
Oh, there's more. Electrons are the tiniest part of all, and they move in circles around the nucleus, sort of like how the planets orbit the sun. Electrons have a negative electrical charge.
So how many protons and electrons are there in an atom?
The number of protons in an atom is equal to its number of electrons. That number determines what element the atom makes. The element hydrogen has 1 proton and 1 electron. It's number 1 on the periodic table. Oxygen has 8 protons and 8 electrons, so it's number 8. Get it? When 2 atoms combine, they make a molecule. Sometimes the atoms that combine are all the same kind of atom. When that happens, an element is created.
What if the atoms are different?
If the atoms that combine are different, then they're still molecules, but they're called compounds. Like water. 2 hydrogen atoms plus 1 oxygen atom equals a molecule of water, H2O.
Wow, atoms really are everything.
It's true. Atoms are amazing.
Seriously, all matter is made up of these tiny particles called atoms. We can't see them unless we use a super strong microscope. There's the nucleus at the center made up of protons and neutrons. Then there are the electrons that circle around the outside of the nucleus. When 2 or more atoms combine, it's called a molecule. If the atoms that combine are all the same, it's an element. If the atoms are different, it's a compound.
So, Sam, still think atoms don't count?
They count all right. Atoms are a work of art.
There are three main parts found inside atoms. We call these parts subatomic particles. They're smaller than the atom. They are the protons, neutrons, and electrons. So our protons are going to live. They're not alive, but you know how we say things. They're located inside the nucleus or the center of the atom. They have a mass of 1 atomic unit. The atomic unit is a unit of measure used only for atoms because they are so small, as you saw in the video yesterday, how really small they are. So it's a unit just for that. So the baseline is the proton. So a proton is 1 atomic unit. The protons are positively charged and located inside the nucleus. They are the identity. You can identify an atom or what element an atom is by the number of protons. So for example, if you had a model of carbon, that model of carbon would have 6 protons in the nucleus. With 6 protons in the nucleus, it cannot be any other element. Any element that has, or any atom that has 6 protons in its nucleus is carbon, regardless of anything else going on with it. That 6 protons make it carbon. Also in the nucleus, we have the neutrons. They are neutrally charged, meaning no charge, 0 charge. They have a mass of about 1 AMU. They're about the same size as the protons. And they add mass to the atom, but they do not affect the charge of the atom or the identity. So the number of neutrons can often vary from atom to atom, but the number of protons will stay the same if it's the same element. Finally, we have the electrons. The electrons have a negative charge. They're located outside the nucleus in the electron cloud, and they have a mass that is too small to count in the overall mass of the atom, so we don't even look at them when we start calculating the mass of atoms. They are negatively charged, and they reside in an area we call the electron cloud. Hopefully you remember that from yesterday. They move really, really fast, and they have almost no mass at all. Most of the mass of the atom is going to be found in the nucleus with the protons and neutrons. Because of the distance between the nucleus and the electron cloud, the inside of an atom, or the volume of an atom, is mostly empty space. Mostly empty space. So the nucleus is the center of the atom. It's called the nucleus. It's not like there's like a sac there. It's not like a cell nucleus, but it is the area where the protons and neutrons are all there together, held by a force called the strong force. So the nucleus is going to be always positive because of the presence of those protons and the fact that the neutrons have no charge. Some properties of the atom. Mass. Mass is the amount of matter in an object. So again, the majority of the mass of the atom is found in the nucleus, and it's made up of the protons and neutrons. And then volume is the amount of space something takes up. And most of the volume of an atom is empty space because there's a lot of space between the nucleus, or the protons and neutrons, and that electron cloud. On the periodic table, when we start working with that, you'll see that the periodic table is set up so that the proton and electron numbers are the same, or you have a neutral atom because those numbers cancel each other out. In real life, that's usually not the case. So sometimes the electrons jump from one atom to another. They are just not loyal. They're like 8th grade boys. They are just not faithful. Little girls better listen. So you could have an atom with a charge. So if the atom has more protons than electrons, then the atom will have a positive charge, and we call it a positive ion, or just an ion. If the atom has more electrons than protons, then it's going to have a negative charge, or we call it an anion. You don't have to remember those vocabulary words. You just need to know that the atom can have a charge, and that charge is dependent on the comparison between the protons and electrons. We discussed yesterday how the Bohr model we know is not quite correct because everything doesn't flow that nice and neatly, but we do use the Bohr model as a visual. And in the Bohr model, the electrons orbit the nucleus in concentric circles, similar to the way the planets orbit the sun. And again, even though we know this isn't exactly what happens, it still provides a good way to visualize the placement of electrons inside an atom, because they are actually in different energy levels, just not quite like Bohr said. So when you are drawing a Bohr model, there are some rules. The first energy level, meaning the first one from the nucleus, can only hold 2 electrons. So if you were drawing this, you can only put 2 electrons in the first one. You can put 8 in the second energy level. Then the third has some icky rules that we don't have to go too deep into for 8th grade. But for you guys, it can hold a maximum of 8. So we kind of stop there, because so you won't draw anything bigger that would require you to use the extra rules. So in actuality, the third one can hold 18 as long as there are other levels after it. We don't have to worry about that. That's a little too much. So if you can remember 288, you're good. Okay. So that's going to be it. Make sure you did that little reflection activity at the beginning. That's on page 68. And I'll see you tomorrow.